the way it works right now, it only applies to array A because the name A is already fixed. We have not talked about parameters in the case of a subroutine. In those cases, yes, it would make it even more flexible. But the way it is right now, you can only use it to initialize array A. But even so, it is useful already because now the number of items in array A is not an issue anymore. So do we have any questions about this code at this point? Now, I don't know what this array is going to be useful for. It could be, each item in this array can be a counter, like, how many times, a person has missed a class. So in that case, I do have to initialize every single one to 0 first, and then I increment it when, someone is absent from the class. Okay. Are there any other questions? Yes, go ahead. It is more like a table. An array is really just a column of a table. It's not even a full table. It is just one single column of a table. Now, some of you probably have heard of what is an array of arrays. In other words, this is a box that contains individual containers already. Can we have a box that contains smaller boxes? The answer is yes, okay? And that's a very powerful concept too, because now instead of a one-dimensional array, you can now have two-dimensional arrays. Because a two-dimensional array is basically a big box that contains smaller boxes, and in each smaller box contains the individual containers. But then you can have three-dimensional arrays, where you have one big, huge box containing smaller boxes, and then each smaller box contains even smaller boxes, and then each of the smallest boxes will contain individual containers. Okay. Any other questions about arrays at this point? No questions? Any questions about the way I trace the code? Yep, go ahead.
Did you ever have like a multiple arrays in one giant super array?
Okay. You can have arrays inside an array, but then you still have the restriction that the types of elements in an array, they must be the same. Okay, so that's one thing about arrays. If I want to draw an array of arrays, I won't ask you questions about this in the test, but since the question was brought up, okay, let's say we have a big box this time. Okay. So this is a big box. We'll call that B. Okay, just so that because we use A for the simple arrays. Now let's just say that this huge big box has 4 smaller boxes. Each smaller box is a long box like this. Okay, so we have 1, 2, 3, 4 smaller boxes, right? So let's just finish. Let me finish drawing the side of the smaller boxes. Okay. Now, because the biggest box is called B, that's the only box that can have a name. The smaller boxes, if you have a box inside a box, the smaller boxes do not have names anymore because they are now elements inside an array. Any element inside an array do not have names. Okay, it does not have a name. Instead, it has a number. So that means this box, this smaller box that is inside the big box, it can only be identified by it is box 0 in the big huge box B. Is that making any sense? Now this part has not changed from what we have talked about, except that each one is not a single mug. Each one is still a big box. The second one will be numbered 1. The next one will be numbered 2, and the last one is numbered 3. Are we doing okay so far? So now the question is, what about these smaller boxes? Okay, box 0 of B now can contain individual items. Let's say it contains 5 individual items. That determines the size and the shape of a box inside box B, but that restriction applies to the other smaller boxes as well. In other words, this implies if the first box of box B has 5 elements, it implies that all the other smaller boxes also contain exactly 5 elements. Because all elements inside an array must have the same type. The same type is basically saying the same shape, the same sizes. Okay. Are there any questions so far? Yep, go ahead.
Can you have a placeholder, a null element? Like, let's say box 0 has, I don't know how you would number them, but they have 5 integers.
Okay.
And
So right now it does have 5 elements.
Right. Now we go to box 1,
Mm-hmm.
and I only need to have 4 elements in
You
that
cannot.
box. Can I have a null element?
Well, you can have a container that has nothing inside, but there have to be 5 containers exactly.
Oh, okay. So I can't have placeholders.
You cannot have the box having a size of 5 and only have 4 containers.
Okay.
When you guys get to the C class, it will get even more confusing because they will start to introduce pointers. And the way pointers are used can be very confusing because they use the same notation as the notation for arrays. But I won't even start to introduce the concept of a pointer in this class. So we're only dealing with arrays in this class. Okay, no pointers. Okay, any questions before? Yep, go ahead.
So it would be like, how would you like that notation be 0?
Good question. Okay, let's just say that inside each individual smaller box we have the containers, and the containers are always numbered from left to right, okay, which is a convention that we usually use. Okay, so the question is, let's say we pick this one out. How do we designate this particular container? That's the question, right? Or kind of the question that you were asking. So we know that this whole thing is box B. Okay, so we know we have to start with B. The next question is, which small box inside B are we talking about? It is this one is 0, this is 1, and this one is 2. So we can now say that B square bracket 2 close square bracket refers to this box here that contains the element that you want to access. Inside that box, okay, this whole thing, B square bracket 2 close bracket, is now an array. What can we do with arrays? We can do the bar A bar thing. We can also use the square bracket operator to access an individual item. So inside that box, this is container 0, this is container 1. So that means if I add square bracket 1 close square bracket, that will identify exactly the container that I'm circling here. Okay. Now that is outside of the scope of this class. I'm not going to talk about two-dimensional array, which is what this is. But since you asked the question, I felt that it is close enough to what we have talked about already. If people can handle the concept, this is not a bad time to talk about it. In fact, if you think about it, if I make this really, really big, like 1024 this way and 768 this way, what does it look like? Yep, it looks like a screen. Okay, so each one can be an individual pixel on the screen. And that's how most programs look at the screen. It is seen as rows, and then each row has individual pixels. So it is exactly like how you access a two-dimensional array. Except in that case, each container is no longer an individual container because there are 3 individual container RGB. Okay. Are there any questions? No questions? Okay. Well, let's go ahead and look at a second example. Let me save this one first, and then we'll take a look at the second one. Okay, let me do it this time. We'll call this array initialization. And then we'll take a look at a new one. I'll write the algorithm first, and then you guys can try to guess what it does. Okay, I get 0. A bracket 0, in this case, gets 1. While I is less than bar A bar, do A bracket I. Okay, I made a mistake here. This one should be 1. A bracket I gets A bracket I minus 1 plus A bracket I minus 1. Yeah, that's a little bit interesting because both the left-hand side and the right-hand side of an assignment statement are using the A bracket notation, and not only that, the right-hand side is using I minus 1 as the index, the left-hand side is using I as the index. We'll go ahead and see what it does. Okay. Well, what is different about this program compared to the previous one? Well, a few minor differences. The first line is a really minor difference, but it is very important. The first line of the previous program initialized I to 0. This one initialized I to 1. But that is actually a very important thing, so I will illustrate why that is important later. And this one also has a array element initialization that is outside of the loop. Okay, this is not done inside the loop, it is outside of the loop. The condition of the loop is exactly the same as the previous one, while I is less than bar A bar. What happens when I does equal to bar A bar?
It exits the loop.
It exits the loop in this case, but why do we want to exit the loop when I becomes bar A bar?
Because we have no more elements in the array.
Exactly. That is exactly right. Very good. Okay. Line 4 is the most strange looking line because now we have array indexing on both sides of the assignment operator. Okay, we have array, A bracket I on the left hand side. We have A bracket I minus 1 close bracket on the other side. So we'll try to go ahead and evaluate what it means. And then line 5 is usual, just incrementing I. And now we'll trace the algorithm, try to find out what it does. I think some of you can probably already know what it does or have a hunch of what this program does. This is line number, this is I. And just like last time, we have an array of 3 elements. It doesn't really make any sense to make it any bigger than that because all I want to do is to illustrate the concept. So A bracket 2 is here. And I'll go ahead and merge these 3 columns. Here we go. In this case, it's basically, go ahead.
You said we have an array of 3 elements, but the algorithm doesn't tell us.
Correct. The algorithm does not tell you how many elements there are in the array. You can only tell either by a statement that I give you, like assume the array has 5 elements, 10 elements, or whatever, or you can look at the initial condition that I have set up for you. So in this case, if I give you this much, that means the array has exactly 3 elements.
Okay, so then we have to look at the trace as well.
Yep.
Work that back in the algorithm.
Not exactly. The trace like this is telling you that bar A bar should evaluate to 3.
No, but if we look at the algorithm itself,
It does not tell you the number of elements. Correct. You are correct. Yep. Okay, are we ready to trace? Okay. Just like last time, we don't need any specific value in anything. Now, it might look kind of strange to you that we can